welcome to Introduction to High Performance Computing. We had some technical difficulties, but now we're here. I am Marcelina Gallus. I'm part of the Research Computing Center, and I'm the software team manager. And I'm here to talk to you about HPC. So our agenda today is what is high performance computing, some definitions that go along with like typical terms that you hear when talking about high performance computing, how to access our HPC here. For those in person, you have gotten login cards to access the HPC, but we'll go through some exercises so that we can practice and get more familiar with the environment, but also I'll be sharing screens during that process so that those online can also see what that looks like, even if they don't have workshop accounts. And then lastly, what support can the Research Computing Center provide for you guys? So what is high performance computing? Two things come to mind. One is specialized hardware. So if you consider the average home computer or just the laptop or tower that you have at home, high performance computer will have more processors than that, have a combination of AMD and Intel processors, so not just one or the other, which your laptop will just have one or the other. And then it can custom house specific types of hardware like CPUs, DSPs, SSDs, and GPUs. And so those can all coexist at the same space. High performance computing allows you to offload your work from your laptop. I know personally, I've run programs on my computer where that's the only thing that it's running for days. And then I'm having to work somewhere else to check email or work on other things. If you use the high performance computer, you can do your research, but at the same time, be able to use your regular desktop, laptop, or device. High performance computing allows you to implement parallel processes. And so this would maybe mean multi-node or utilize all the cores within a node for a given system. And then it allows you to kind of batch process those tasks that need to be repeated a bunch of times over a long period of time. So at the Research Computing Center, we have statistics on our high performance computer. We have almost 650 nodes, and we're running Linux 8.6. On those nodes, 114 GPUs, and those are the different GPUs that we have currently. Roughly 20,000 processors, both AMD and Intel, and then almost 960 teraflops for CPUs. And I'll get into what jobs are, but we have had submitted jobs 29 million since 2008. So HPC definitions. When you are running a program on your computer, you take your program and your data and you can just click run, right? So what you're going to do for a high performance computing job is you're going to submit your data and your program to the HPC. So you've seen like a server room. That's essentially what our HPC is. It's located in Innovation Park. And so you'll be able to submit it to these compute nodes remotely, and then it'll provide you some output from the results. So instead of having it on your local computer, running the data and program there, and then getting the output immediately, it'll be a similar process, but you're just sending it out, and then it's coming back to you just that way. So the high performance computer is a shared resource, all FSU researchers. And so we use this thing called the job scheduler, Slurm, so that way we can kind of allocate who gets what resource and how much people need. Because if we just kind of let people submit their programs and try and run them, it's possible that the cluster can freeze up if we don't have enough resources to process all the jobs. So we'll talk about how allocating resources works, but I think the best analogy that I have for it is essentially your data and program are in a box, and when you're shipping that box, you need to have a label of where it's going, who it's going to, how much does it weigh, and so all of that information goes on the label itself, and that's what we'll be doing as we go through, is trying to make sure that we're labeling our data and program correctly so that we're allocating the right resources. So on the high performance computer, you'll see that you have your own user accounts. So for example, the workshop accounts that you guys have received are similar to user accounts, but our workshop accounts are strictly for workshops and they get reset after every workshop so that we can continue to use it for other workshops. You'll be able to log in, you got a username and password, and you'll have 150 gigabytes of your home directory. So something that comes up is Slurm accounts. And these are different from user accounts because these are essentially different like lanes you can allocate resources to. And they have different limitations depending on which Slurm account you pick. Since you guys have workshop accounts, we'll be using the workshop Slurm account. But there are general access ones for all of our free users, and then there are owner Slurm accounts that are particular to any research or lab that has purchased their own like specific resources for allocation. So another way to think about the job scheduler is that you send in your data and program in a box, and it kind of waits in line with everyone else. Sometimes if the box is smaller, so your data and program will take less time, it'll kind of jump the line. If you're using GPUs, that'll make the wait time longer. So this is a good representation of all of our general access queues. And this green box over here is a representation of what the owner Slurm accounts are going to look like. So you won't have to kind of compete for wait times if you're the only one running, but if you have multiple people in your lab that are running jobs, then it'll look closer to this. It also depends on how many resources you have within a given Slurm account. For example, some of our Slurm accounts have the newer nodes, but then the limit in terms of runtime is 4 hours, and then our general access queue has a limit of 14 days of max time run. So it just depends on what your needs are. So I know I went through that pretty quickly, but does anyone have any questions either online or in? Anyone online?
Yeah, give them a second to type that.
So yeah, so I'll just jump straight into how to access the HPC. Again, for those that have the workshop accounts, you'll be able to see already. Once you log in, you're technically already working on the high performance computer, but we'll go through and do a deeper dive. There's two different ways to access the HPC. There's the command line interface, which is text-based, and then there's the graphical interface, open on demand, which is what the workshop accounts have access to. So it just depends on what you're comfortable with, but they're accessing the same space. For the command line interface, this is you're able to access it using any SSH command because RCC uses Linux on the compute nodes and the login nodes. If you're curious about how Linux works and don't have experience working with Linux, but you'd like to learn, we have an introduction to Linux workshop at the end of September in this very room, and then also offered online, I think around the same time. So Tuesdays at 3. So, and that'll be hosted by Ja, who's here. So other aspect of this is the open on demand applications. They're split by the particular applications, but there's also a desktop version, which allows you to access whatever program you need, as long as you need to use a graphical space, but you can also access the terminal within here. And this is an image of what the desktop looks like. If you've used MATLAB, RStudio, Jupyter Notebooks, it'll just look the same as it would on your local computer, but you'll be using HPC resources. So for those that are here, you might have already gone to ood.rcc.fsu.edu We have a couple different URLs that lead to the same place, but this is our link for open on demand. And then we have additional documentation if you are curious about all of the softwares that we have or any recommendations that we have in terms of resource allocation. So let's see. So the big difference, or one of the differences between open on demand and an interface is the file manager. So this is something that looks a bit more similar to a file explorer on your computer. So you can click on folders and view files in this space. And then you can kind of see what's different between your local computer and HPC, but this allows you to upload and download small files. There is a limit on the size of the files that you can upload and download in this space. However, we have documentation talking about data transfer using Globus for larger data files, depending on what you need. And we'll go into this also when we jump into more of our interactive session, where we can edit files and we can delete and move files if necessary. So it's a little bit easier if you're not familiar with the Linux commands to do this in this space, or you can do this also in the desktop. So when you go to submit jobs to the HPC system, I talked about resource allocation, and they look different depending on if you're going from the command line interface side or if you're going from the graphical user interface side. For open on demand, graphical user interface side is a lot of clicking and some typing. So you'll be able to log in to ood.rc.fcu.edu. And once you log in, you'll get to this landing page that has a bunch of different options. So you can go to the particular interactive sessions that you want. There's like a command line interface. You can look at the jobs that either have been submitted within a given Slurm account, and then you can also look at your files. And we'll actually switch over. I'll show it to you in this space instead. So sometimes you'll get something like this in terms of error. We'll just to our login and try again. So once you get to this space, this is our dashboard. You'll see latest RCC news, but you'll see pinned apps as well. So if you want to kind of see how you implement interactive apps or graphical user interface, we can just start with RCC desktop. And this might be a little bit different from yours in terms of what's in the blanks because it saves what is last inputted. So we talked about Slurm accounts in terms of the allocated resources that are specified. Since you're in your workshop accounts, we'll use workshop. And then for our number of hours, 4 is a little bit much, but that's so that we know that it doesn't expire. In on demand, it will not expire until that time frame, until it times out from that initial request. So what you can do is you can exit out of here, log out of your computer, shut down your computer, head back home. If you open up to your computer and you're on the VPN, you can come back, access this page, and it'll still be running like you've had it open this whole time. So again, that offloading your workload is that bonus benefit of using the high performance computer. So, unfortunately for in this space, you can only put number of hours. So if you're in a Slurm account that will allow you to run things up to 14 days, you'll just have to convert it into hours. For the amount of memory requested, this is the total amount of memory per node. It's important that you put the G here for gigabytes, because if you don't have a letter there, it automatically assumes that it's doing it in megabytes, and typically that's when we see researchers running into errors of out of memory. So make sure that you include that. Typically, our default is going to be 2 gigabytes per core. But oftentimes you'll see a max of 4 gigabytes per core. So that way you can let the computer do the math for you, or you can make sure that that just works math-wise farther down. Typically, we recommend 1 node for the number of nodes, as most of the times if you're just going straight from your local computer to the HPC, it will not be automatically parallel, and so will not run on multiple nodes. If you try and run on multiple nodes and your program is not parallelizable, it'll just run the same program on both nodes, which will take it'll take up more memory for like essentially not any extra efficiency. You'll be running the same thing. If you have 2 nodes, you'll be running the same thing twice. So we recommend number of nodes to be 1, and then you know that your code is not parallel, you can just increase the number of cores, and that'll still be more powerful than just running it on your regular computer. The last parameter that we have on here is GPUs. You can add these if you know that your code needs it. Otherwise, we recommend that you don't add it because it'll dramatically increase the wait time. I know that we said that we have around 115 GPUs available, but those are also out of 650 nodes. That's a relatively small amount. So you'll be waiting a decent amount of time to run your code with GPUs. So if you all have been following along, you can click launch. And first it'll start off with this queued status. It'll just be waiting again to move up in that queue, move up in the Slurm account so that resources can be allocated. And there'll be, it was very quick, but there's a starting status as well as a running status. So when it has a running status, it has this launch RCC desktop button. And then here you can see exactly what node is running your job. So it's the M36-2-6 is that node that's running your job. And if you ever need any troubleshooting issues, the session ID is what's really helpful for us to kind of figure out what has gone wrong, because it keeps a log of everything that's happened within that session. So go to launch RCC desktop and it just looks like a regular computer. This is that file. This is similar to the file explorer that I was mentioning in Open On Demand, but again, it's the same system. It accesses the same space, but you can just go at it from multiple different spaces. So you should see these folders as well as these two, and we'll get to this one a little bit later. And the last bit in this space is, I mentioned the command line interface as a way of interacting in terms of jobs, and we'll be using this later on in a different example. But that terminal button is going to be, that's super visible to those in person, but it's going to be on the bottom dashboard, that second square with the silver around it.
I think I missed something because my desktop window doesn't look like that.
Oh, okay. Yeah, actually, let me shift back over. to, and then also Je can come around and help, if anyone has any questions.
I have a question.
Yeah.
Kind of optional. Which version of GNU?
Yeah, so since it's optional, we'll just leave it as,
How do we use it on the or RCC desktop?
you can just leave it for now because we'll use it for the command line exercise later. So the Slurm account should be working. If you launch MATLAB, it should, yeah, have a blue square like that. Yeah. You able to do the MATLAB example?
Yeah.
Okay. No worries if not. I know that it's not relevant to everyone's research, so just practice and
My account is having some trouble because it's saying fail to connect to server. Better.
yeah, so delete. Back to
Delete the previous one.
oh no, you can leave that one. So cancel. So amount of memory, you gotta put a G after it. Yeah. Plus it'll, and then I think that should be good. Launch it. Have MATLAB, that we're on a local. Okay. So. Right, so. For the command line, when we are submitting jobs, we have a .sh file that we use to specify all of the things that we specified in the parameters. For the open on demand. So this is an example of what a basic submit script is going to look like. So the -J in here, we can specify what the job name is. When we're submitting things in open on demand, it'll automatically specify what the application is that you're using. So for example, we'll be able to see like who submitted RCC desktop jobs as well as the MATLAB jobs. Our -A is going to be the Slurm account. Backfill 2 is one of those available for free use. This one will have the newer nodes, but the default limit is the maximum limit for the time that you can run on the newer nodes is 4 hours. The -lowercase, going through so fast. The -lowercase t is going to be your time. It's more flexible with the command line jobs than the open on demand jobs, because you can specify the minutes, the seconds, and the days if you want, instead of having to calculate what the time frame is in hours. And then we'll have a slide later that talks about all of the different limitations, and it's also listed in our document. The amount of memory that gets requested is the --mem equals 16 gigs. As you can see, the letter is important. Again, if you don't have it, it's gonna default to megabytes and you'll get an out of memory error. It's likely because then you'll be asking for 16 cores, 1 node, and 16 megabytes. If you don't specify the memory, it'll just do the math for you in terms of the default. Sometimes it'll be 2 gigabytes, sometimes it'll be 4 gigabytes per core. I would just check the documentation to make sure, or you can specify the memory itself. The number of cores is our lowercase n, and then our capital N is our number of nodes. And then typically we recommend doing just 1 node. You know that it's not parallel, or if you're not sure if it's parallel, then probably 1 node is your best bet. And then this line here is for having 1 GPU. And if you don't want it, you should just delete this line entirely. Because as you can see, all of these S batches start with a # already. So if you try and put a # again in front of it, it'll still read it and it won't take it as a comment. So just so that you're not having to wait a super long time if you don't need a GPU. The last couple of bits on here are the commands that you would run if it was just within the command line. The module load that we do, since we have a bunch of different libraries on the HPC, you have to specify which path you want activated. So for these, the module load GNU and OpenMPI will enable and activate the GNU libraries and the OpenMPI library paths. So for example, this executable file will only run if the GNU libraries and the OpenMPI libraries are active. And then lastly, we'll run command so that we can enter in our data and our program. So this is like specifically translating each line by line, but we figured we'd give you individual slides to talk about what's happening in each line. Does anyone have any questions?
I assume that this way of like creating a job would be through the CLI instead of using the OOD, right?
Yeah, so we'll actually, so yes and no, you can do it just through the command line, but you can also do it within the desktop if you have specific things, but you still want that graphical interface. And we'll actually go through that after this.
Can you repeat what does backfill 2 mean?
So backfill 2 is a Slurm account that's that has different criteria than the workshop account. For the workshop Slurm accounts, if you have a workshop user account, that's the only way you can access that Slurm account. But backfill 2, anyone can access it, but it just has specific limitations. So backfill 2 will have newer nodes, but the maximum time that you can run a job on there is 4 hours. Question?
I have 2 questions regarding them using the MATLAB. I don't know if it's the right time to ask them. So what if I want to have some package installed in MATLAB? So that I should cover with some other workshop, right?
Well, yeah, so if you want specific packages installed into MATLAB, we'll install it on your home directory and you'll have access to, like, you'll be able to access it within that MATLAB space. The difference between that and just being able to install it on your local computer means that if we were to install it for everyone on the HPC, then it would load whenever anyone would request MATLAB. And we don't want to overload anyone who wants to use MATLAB. And that's why we also have different versions of MATLAB as well. So depending on what you want, we can install specific packages for you to use. Yeah. Any questions online?
What's the maximum memory available for a job?
Depends on the Slurm account, and we'll go into what, backfill two, GenAC Q, backfill. I think Condor and Quick Test are also on our general access like list. So basically, like the Slurm accounts that you don't have to pay. But we'll go through that at the end. Unless it's the next slide. Okay. So remember how I said to keep your RCC desktop open and running, especially if you have the terminal active? You should be able to enter these commands and submit a command line interface job. So I'll go around if anyone has any questions. When you type in this last line and press enter, you'll get an output that will return a job ID. And then we'll go look at that file after. Like, when you run this first line, the srun export all trap.x, that's what it looks like when you submit the code itself just to the terminal. So you'll see that it says number of processors 4, and then it does a trapezoid calculation. So then our sbatch script will have the same output, because we're running it on the same nodes. So as you can see, you sbatch submit trap.sh, you get a submitted batch job, job ID number. And then when you go into your files, you'll see that there's a matching output file with that same corresponding job ID number. Your job ID number will be different from mine because all of those are unique, which is why we asked you to include them in your saying that you run into errors, so that we can find the particular job that was having issues. So, so how we check on those? We flip back to where we were in the Open On-Demand dashboard, go to Files. This is the same set of files that we were accessing before, but just in a place that we can actually check things out. So if we want to just view what's happening in here, select View. So this says that I ran into an error for mine, which means that the command itself that I ran was buggy. So let's go in and we'll check what's happening in our trap.sh. So, did anyone else run into that same error? Yeah. Okay. So let's open up this submit trap.sh and we'll actually click on edit instead. Yours might look a little bit different from mine. I would say change yours so it matches mine.
Is it that it's missing like the memory requirement?
So for this one, the memory requirement will be whatever we specified it at since we're running it already with the parameters specified for RCC desktop. Yeah, what we should be getting is something looks like this. So the same thing that we got on the home screen, or that we got directly to the screen. For some reason doesn't. Did everyone have workshop as their -A option for this? So yeah, so if it wasn't set to workshop, I would say change it to workshop and then we'll see if we can't specify. Here. Well, theoretically that works. I'll figure out what I ended up doing here, but that is a common error that we end up having in terms of memory. But essentially, if you're creating it on RCC desktop, you already have a space here, you can just run it from the terminal. So with this command that we have here, and that'll run within that time frame. You have it set. Does anyone have any questions about the command line? Or the submitting prompts? Yeah.
Currently running an issue right now where when I edit the file submit draft.sh, I hit on the save button and when I check if it has been modified or not, I can see that it was modified, but when I check the file itself, it doesn't save the changes that I made.
Okay.
So I made the correction.
Uh-huh.
I clicked save, refresh the page, it says that it was updated. When I click on it, still shows.
Oh. Mm. So this one might just be. Might not have given. Well, no, we have it right. I guess, if you click on edit again, will it have it changed? Yeah, save it. So, yeah, so you gotta click refresh.
Do you work on them?
But I think it's just, hold on a minute. It's-
49 you said?
Yeah. No, it's not, I have. Yeah, but if
Submit
you,
draft?
right. But so if you go back to the terminal. Yeah. So do tilde actually, so CD. Yeah. And then, yeah, so LESS, like less. And then submit, LESS. Yeah, and space, and then submit. Yeah. So for some reason, it's just the file explorer on Open On Demand's having issues. Yeah, so it is recording. Okay. All right, well then. Okay. So, yeah. Are there any other questions? Online? All right, so lastly, what is the support that you can get from the RCC team? I know that I mentioned briefly Research Computing Center, which is also RCC, but we're a unit of the IT department. We used to be a part of the scientific computing department in 2013. So we host and administer any maintenance and facilitate research for the main supercomputing resource, the HPC. So right now you all are using, those in person, they're using workshop accounts. If you'd like to register for your own account, you can. If you are a student, you'll need a faculty sponsor. If you're a faculty, then you should be able to just create an no, actually you should have your FSU ID and password will be the only thing that you need to log in. Students and guests will both need a faculty sponsor, but that's just because of the rotation that we have for students and non-FSU collaborators. We just want to make sure that there's a responsible faculty member that can vouch for you. The physical location of the server room is held in the Sligo Data Center in Innovation Park. If you're curious and are interested in a tour, we do tours whenever they're requested. And so you can see the system looks like you can, will be able to officially know what we mean by you'll know what we mean when we say that the node is M36-2-6. You'll be able to find that exact node in the cluster, which I think is always a fun scavenger hunt. The standard RCC accounts come with one home directory per user, 150 gigabytes, temporary scratch space if you need it for running jobs that create a lot of temporary files when you're running it. This gets cleared out on occasion. You'll have access to the general access and backfill queues or Slurm accounts, and then you can also have access via Open On Demand and the command line interface. So we additionally provide available for purchase parallel and archival storage systems. So something more akin to like Google Drive, where you can share resources with your lab members. Archival storage systems, if you have a bunch of data and you'd like to store it somewhere, and you don't want to have to store it on a local computer, we do have that archival storage space. I mentioned before that you can purchase allocated resources for your own Slurm account, and this can be either in the process of specific amount of cores that you'd like, specific amount of core hours, as well as like GPUs. And that's all the need. So for the general access Slurm accounts, for the question online that was asking what's the maximum amount of cores per job, here you go. So these are our Slurm accounts that are free to access. There's also a website that will allow you to view all this information. For some, you can see they're 14 days for default runtime and max runtime. So that's if you don't, default runtime is if you don't specify it either within Open On Demand or the command line interface. And then max CPU cores per job is not necessarily per one node, it's just per the job itself. And then you're also limited by the amount of jobs that you can submit, and then the amount of jobs that you can have running versus the ones that you've submitted as well. So how do we help? So right now, and I'm sure you've seen maybe on the camera, or so Alex is here, and he's our senior application specialist. Shah is also an application specialist. And then we have Jose, I think online, that helps with our digital humanities applications. But what we do is we help with software installation, maintenance. If you're having issues with any applications or errors, we also help with giving you examples of what it will look like to parallelize your code if that's something that you need, and just kind of working with any other commands that you would need in the HPC. If you have hardware that is it within your lab that you would like to transfer to the data center and then access it that way, and that way you don't have to handle the maintenance of it, that would be on RCC. You have data center colocation as an option. For additional paid support that we provide, we can help with like specific software development consultation of like complex software, and then just like more in-depth consulting for research projects. And this is because we're just a small team. So here's some software that we provide. We have it split by department, kind of. We had different categories in terms of the software. I think in a future slide, maybe the next one, we talk about how many different software we have installed. If you don't see the software that you need on our list and it has a Linux installation, then we can install it for you on the system. So we have over 600 software tools managed and supported. I said that we had 29 million jobs submitted, so an average of 2 million jobs per year submitted to the system, and then we've also helped with support cases. I think that's an old number, but we have helped with support cases since 2022. In terms of technical support, even like creating user accounts, anything. We work a hybrid schedule. For regular office hours, we're available by Zoom or by email. We're actually located in the basement of Dirac, so you can walk in. We prefer if you let us know, since we may or may not be in the office. Might be remote working. If you require any additional resources for high performance computing, we have a HPC driver's ed, which takes you through the command line interface, as well as the open on demand, and then our three typical languages that we see in terms of programming. So Python, R, and MATLAB. So it'll take you through some of the troubleshooting you might run into for that, and then how to operate the software on our computer or on HPC. And then lastly, we have our docs.rcc website that has all of our documentation. So all of the software that we have is documented on that. We have some tutorials, but just let us know. Some software is only available for particular groups. So again, let us know if that's something that you're interested in. And then if you have any questions or concerns, you can email us at support@rcc.fsu.edu. And yeah, I will say that these slides will be sent out along with the recording of this workshop after workshop is over. I think maybe give it a week or so to get everything, for us to get everything. And are there any questions? Online? All right. Please let us know how we did on this. I know that it was kind of unavoidable, the technical difficulties in the beginning. But if you'd like to just let us know how we're doing, any changes that can be made for this workshop, feel free to let us know. And that's it. Yeah.
This is like very general because first of all, my friends and I are all undergraduates, and like we saw about this and we were kind of interested in like knowing about high performance computing. But since we're like so young, we're still discovering what can we do with this. And I don't know if you have like any recommendations on what to explore to see what we can do with high performance computing in general.
Yeah. I think in a previous iteration of this presentation, we had different research projects that we presented, but there's applications in machine learning that you can do on the high performance computer. I would say any programming and any data visualization. So for example, we've done, at least on the digital humanities side of things, we're creating a network graph of women pedagogues within a given time frame and trying to figure out how they all connect in terms of like their roles and organizations, and just kind of like a database. What else? There's been a lot of research in the biostats space. And we have specific software that really is really difficult to run on your local computer, but we also have, I think, a weather forecasting software called WARF that you can map out. You can, given like a particular thing, it will predict or show like the forecasting of weather on a given area. So a lot of like larger data sets Alex, do you have anything?
A lot of chemistry software.
Yeah.
Doing quantum mechanics or molecular dynamics. We have a lot of things. A lot of physics and engineering gets done. Physics and engineering simulations get done there. Work is only one of. So, a lot of big. So, anything that if you try to run it on your laptop, laptop's going to catch fire. That's probably when you want to move to the supercomputer.
Well, since we're all students, in this case, how do we reach out for a faculty sponsor?
Oh, you'll probably want to talk to. So you'll probably want to find a professor that's teaching a class on high performance computing or otherwise uses high performance computing. You'll want to ask them to be your faculty sponsor. That's probably your best. A lot of faculty have HPC accounts. So basically any faculty.
Yeah, I have a question. So in requesting for an account for students, you need a sponsor, right? So does the request come from the sponsor or student?
So, yeah, when you create your user account, there'll be a drop down for the
Okay.
sponsor, and then the sponsor will then approve or deny your. Yeah, so then if you don't see your sponsor on the list, just let us know at the email. And then we'll add them.
And in case we want an application that's not already installed, we also email you that as well.
Yeah, so I would say, yeah, email us at this email and then just provide us as much documentation as possible. Because we may not be familiar with that particular software, so any documentation you have will be helpful for us to install it, yeah. Awesome. Well, thank you guys for coming. Hopefully see you at our next workshop at the end of September